Test 1, 2, 3. Are we live?
Mm-hmm. Yes, we are.
Okay. Hi, guys. I'm going to start. I'm going to use the microphone because we're being live streamed. So I think it's going to be easier for people watching the stream. And also, if you don't want to be streamed, don't walk in front of the camera. So I'm here to introduce the DutchX to you. Welcome to the developer workshop. I've brought two super great developers. We have David over here, who's largely built front end tapping into the DutchX protocol, and we have Alex here as well, who's written largely the smart contracts governing the Dutch exchange. Myself, I'm the product manager of the Dutch exchange, and what we do is for the first 20 minutes or so, I'll introduce the mechanism behind the DutchX and what the DutchX is and what kind of the token format, etc. to you, and then I'll hand over to do some integration into the DutchX, and we have those two to give you a showcase of that, and in the end I'll give you some ideas what could potentially be built on top and follow up with some information that you might need if you want to take part on the hackathon this weekend. Yeah? Cool. Let me start. So what is the DutchX? It's an open trading protocol for ERC20 tokens, and it's using the Dutch auction format to find a fair value for tokens. So how did we come about, or how did we land there? If you look at traditional centralized and decentralized exchanges, they're traditionally arranged in the order book model. What you have in an order book model, it's more continuous auction, which leads to discriminatory pricing. So you can see here order book with the bids and the asks, and you can either place kind of a limit order into the order book or execute a market order, which would be at the best available price. Discriminatory pricing in the sense that everybody will get a different price depending on where they are in the order book, and continues in the sense that as bids and asks come in, they're being filled whenever the order can be filled. That can lead to fronting, a practice of when information is available ahead of time to participants, for example, participants or the exchange miners, also leading often to high-frequency trading. You might have overlapping order books, another problem that is prone to order books where there is no automatic matching of the orders, and oftentimes, especially in kind of illiquid markets, you have big spreads and a high slippage being that the order book and the price moves a lot because there's not really a lot of volume in there. So we thought that's not very easy to take to the blockchain, because in blockchain, we came up with an entirely different model that we thought works much better on chain. So we apply for the DutchX. We applied two different auction formats. One is the batch auction, which means as much as we're batching tokens together, to then apply the Dutch auction format, which is, I don't know if you're familiar with the Dutch auction format, it's really an auction where you start with a high but falling price, and the market clearing is where all the bids times that price matches all those sell volume. And it's actually particularly cool because it incentivizes the bidders to really take part at their highest willingness to pay, because everybody ends up paying the same price, which is the lowest price. Okay, so you can only have a payoff if then the price continues to drop. So how do we apply this in our model? So as I mentioned, it's two stages. Let's go through the option that somebody would like to exchange token A for token B. So in this example, the token A would be the sell token and the token B would be the bid token. So you have two stages. One is prior to the Dutch auction start, which is the time leading up to it, is where all those sellers, those who want to sell token A and receive token B for it, have the chance to deposit it. After the deposit is then closed, finalized, nobody can enter a running auction when the auction has then started in the second steps where the bidders are active. So you have these two stages. And how does that look over time? So obviously you have this for all kinds of different tokens, can be any kind of pairing. I've just put here token A, token B for you. So this is on repeat, so to speak. So you only ever have an auction at one point in time. So you have that depositing phase, you have the auction phase, and then after the auction clears, tokens can be claimed. And during that phase of the auction, those who want to deposit, so those who want to sell token A, may already deposit into the next auction, but it will only start once the first auction or the prior auction has finished. So there's only ever once, and then you have this for any kind of token pairing that is added on the DutchX protocol. You have the same kind of mechanism and rhythm. They're all independent from one another. So let's look at kind of the tokens and the design and the token engineering that we've used for the Dutch exchange. So we have three kind of critical things to take note on for how the mechanism works. One is what we call Magnolia. It's an intrinsic token to the Dutch exchange. It's being minted for every trade that you make on a whitelisted token. And one ETH or a fraction thereof equates one Magnolia and is minted by once the user is claiming their tokens. So they're locked by default, and only locked tokens can be used for the fee reduction, but any user may also unlock them, and within 24 hours they become transferable, and they could be traded on secondary markets. What do Magnolia do? They are merely used for fee reduction. So the more you trade, the more Magnolia, the lower your fees. It advises people to be on their early on and to stay on the Dutch exchange. It goes down to 0% fees. There's another option that users may pay half of the remaining fees in OWL. OWL is another token. OWL is a token that is gives GNO, the Gnosis token, its utility and is generated by locking down GNO. This is completely optional. No tokens are required to be active on the DutchX. So what happens to the fees that are levied on the DutchX? Fees paid in OWL are burnt. They go to no one, but fees paid in the participating token, which is the only other option that you pay your fees in, if they're not down to zero, if you haven't reduced them to zero, the fees, then you have some kind of fees, you pay them in the participating token, and they get reallocated within the ecosystem by being attributed to an extra sell balance of the next running auction, one, giving more liquidity, and also benefiting for those who are heavy traders on the DutchX. They might benefit from others paying fees. So it's really an incentive mechanism designed to for users of the DutchX. So kind of some advantages that we see with this mechanism that we apply. So there's no front running, as everybody pays the same price, the same lowest final price. It also, by the fact that it's actually quite slow, reduces the volatility. So there's not massive fluctuations in the market. We also believe it's a much fairer price finding mechanisms by applying these auction mechanisms. There are also no gas costs incurred by traders trying to fulfill the same order. And not lastly, but obviously due to the speed, you also don't have high frequency trader, which in our opinion really extract value out of the exchange or the market. With two other exchanges, two other advantages, which I would like to outline separately. One, really the smart contracts were designed for other smart contracts interaction, meaning everything happens on chain. There's no need to sign any transactions off chain or receive any transactions off chain. And what's really cool, the outcome of this is also to be really a on-chain reliable price oracle. So sort of these two advantages lead us to what we call the open protocol, which we really think the DutchX is a protocol for others to build on, and I've just highlighted here 3 separate layers where you could really see dApps or smart contracts building on top. So you have on the lowest, I put the smart contract interaction layer, where just a few examples are, for example, a transaction scheduler or lending, buyback contracts, etc. You have those fully fledged apps that might just be in need of exchanging a token. These could, for example, be the outcome tokens of a prediction market, or a DAO who wants to exchange or some tokens. Then you have that interface level where we see sort of seller interfaces, those active as the seller in the first step, and then bidder interfaces, as well as various wallets integration. So kind of this all gives the liquidity, and then the outcome of this is also a price feed, which in turn can also be used by all various kind of dApps. Right, so now you might wonder, so how does the architecture look like of the smart contracts? So in case you do want to build on top, I'm just going to outline the few smart contracts that govern the exchange. So it's set up as a proxy contract, which means it makes the DutchX contract upgradable. So all the logic is in the DX master, but all kind of prior information, history, transaction history is in the proxy. So the proxy always rests the logic of the DX master, returns the logic, and then you have a separate, so all these boxes are actually separate smart contracts. You have the fee reduction contract, where you have the Magnolia attached to it, and then we have one external price feed. So this is the integration price feed. We use the MakerDAO price feed. I don't know if you're familiar. And then again, here also, this is not really part of the DutchX, but also contracts that are being used are the our contracts, which are set up exactly the same way with the proxy as well. Cool. So I think just in other news, we're already live for many, actually months now, maybe 2 months on the Ethereum mainnet, and it's running really smoothly, the smart contract layer. And I would suggest, if you have questions to the mechanism, that we get them now, so that I can then hand over for some hands-on integration on the DutchX. Does that sound good? Do you have questions? It's okay if you have none. No? Okay, in that case, I would hand over here.
Yeah, you can even be at the very beginning. No. All right. Thank you, Chris, for this very good introduction. My name is Alexander Herman, and now I will show a little bit how you actually work with these contracts, how you integrate them into your smart contract system, how you easily make them interact. And I've heard that some people of our audience that they're working on DAOs, and I think that's a really good match, because with our auction mechanisms, these DAOs, they can perfectly sell tokens. Like many of these DAOs, they need to simply liquidate some tokens, and with this protocol over here, we can very easily do that, and you cannot easily do it on other exchanges, for example, Ether, Delta, and so on. And yeah, we will not really look into these examples, but I brought some other examples, and yeah, I hope you like them and that you will follow them easily. So we set up a website. You can find it on our GitHub, Gnosis, DX examples. So that there we have some examples where you can take a look into it, and we will now also walk you through these examples. Great. if you want to get your hands also dirty, I hope that you're connected over here with the Wi-Fi, and then you can just do all the steps together. I will first present like basically a batch of steps, and then if you have questions, just raise your hands, and after I finish this batch of steps, we will just talk about this questions for shortly. Cool. Thank you. Okay, so this one is now the main website where we have all the examples. We have one, the first one, which is simply building out of, built on top of the DX, where we simply integrate all the smart contracts into just an empty truffle project. And then the next one is really an example where we're using the Dutch exchange as an oracle. And then later on, David will move on with some front end stuff. So let's begin. And let's take a look into the first one. So now what we really want to do is setting up a new truffle project and pulling all the dependencies easily in. Like, what is your background? Have you worked already previously with truffle? Are you familiar with it? Okay, that looks good. So then I will go through these steps a little bit quicker so that we have later on a little bit more time to talk about the other stuff. So basically at the beginning, we are setting up our truffle project manually. We don't use the truffle in it, but we want to have full control over it. So we're creating at the very beginning a new folder over here. We're going into this folder, then we do the npm init in order to basically set everything up with npm, give the project a name, and so on. Then we create the git init. We also do the git init in order to make it a GitHub repo. We are setting up the git ignore, and then what we are doing as the next step is really setting up truffle with a predefined version, because like the smart contracts, they are written with a specific version of truffle. And for example, they're using old syntax of Solidity a little bit because our project is now a little bit more mature. And because of that, you basically need to get these truffle versions. So I did these steps already because they take just a little bit of time. You can see over here, I created this my cool devs, switched into it, did the npm init, and then installed these things. So, and from now on, like everything that is being done over here in the description, I will also now really do here on my computer so that we can all do it together. Good. Then the next step, what you're usually doing is setting up the truffle.js. And over here, we're basically using our own template, but which is very, very similar to the template all the other projects are using. So we have some variables that we can define, for example, the gas price with which we want to deploy stuff, with which we want to talk to the smart contracts, gas limits. We really like to work with mnemonics because they create all the time the same accounts. They make it very easy and handy to interact with them. And then you have the stuff that you always have, basically, that you do a setup for the different networks for development, for the mainnet, for Rinkeby. And yeah, with that, everything is set up, and you basically are able to talk to these different networks. So we create this very quickly over here. Paste it here in, and yeah, there it is. Okay. Okay, now I'm really in the right folder, and over here I create now this new file, truffle.js. Bam, there it is. And then we are moving on. We create a truffle migration. That's all. That's always the migration Solidity file you need for later on for the migration. It deals with the migration steps, and then we set up the initial migrations. So I'm doing that very quickly. Bam, migrations is created, and now I just need to create the first initial migration script that is basically all the time the same for these projects. That's this one over here. Show migration.js. Oops. Good. So this is really just the very basic truffle setup, and now we really want to come to meet, and we want to integrate all the dependencies. So for this, we have an npm package. Over here, the link is at gnosis.vm dx contracts, and you can just pull this easily in, and then you have all the smart contracts. I'm also doing it very quickly, installing it. It's pretty straightforward. But then there is one thing that Truffle, at least we think Truffle is not yet really well taken care of it. Like, you can easily install these npm packages, and but then you also need to make sure that Truffle pulls out these contracts and really compiles them. And either that means you need to include them into your Solidity files, or you pull them in with something like dependencies Solidity file. So we show you here an example. For example, we created here these cool depth dependencies Solidify that does really nothing. It just pulls in all the dependencies which we are having from the Dutch exchange. I really hope that in the future this gets a little bit easier. One of our team colleagues already submitted PRs to Truffle and so on. But yeah, until now, we have not found a very good way or a better way how to do it like this one. So let's just pull it in here. Creating this new one. Cool. Tab. Okay. So. Okay, it's called add dependencies, sorry. It's just that the contract name and the file name need to match. Okay, now we are having all the dependencies, and now let's see whether it all compiles. It pulls here, you can see in that it pulls in all the smart contracts from our dependencies. Pretty straightforward, and it compiles them. So this was really the easy step. Now the next one is a little bit easier, a little bit harder. You want to also make sure that you're using the same migration scripts as we have, so that you can easily test them, these smart contracts later on. And for this, we have written our smart contracts and the migration scripts in a specific way, so that later on you can really easily use them. And so basically, you just need to include these small statements into your migration script, and then it really pulls on all the logic from the Dutch exchange contracts, sources, migrations over there, and then really migrates all the different smart contracts. So there's quite some logic, and they need to be deployed in a certain order and so on, but this is all taken care of for you with these nice scripts that we created over here. Okay, let's see whether that works. Shuffle migrate. I'm not sure for that. For sure, you need to have Ganache already started in the background. I did this already previously, and yeah, now you can really see what is all deployed for the Dutch exchange. It's quite some smart contracts. We also depend on the maker DAO price feed in some sense. We are deploying wrapped Ether contracts so that you can easily work with wrapped Ether. We do price oracle interfaces. We are deploying GNO token because with them later on you can issue BIS tokens, which allow you to lower your fees, and there's quite some meanwhile. But the good part is you do not really need to understand that like very much in detail. You can basically later on just use the main functions of the Dutch exchange and easily talk with them. Good. This is already like the first setup. This is now basically the empty truffle project from which you can start on building on. Any questions? Good. Then now we're doing the first application, basically use it as an oracle. We are really keeping it here super simple, just to demonstrate how it works, but yeah, it's really nothing fancy. I know that you will come up with much, much cooler stuff during the hackathon. So if we are looking now at the documentation, it basically says, yeah, do all the steps from the example one. We did this now together. And now you can create new smart contracts in your truffle projects. What we will do, we will basically create a safe where you can deposit tokens in and where you can withdraw tokens from. And over there, at some point you want to know like what's the value of all your tokens in the smart contract, in the safe. And for this, we use the Dutch exchange because with the Dutch exchange, we can easily get evaluations of these different tokens, and then, yeah, you can get it easily displayed. So it's a super simple application, but still a nice one. So we can take a look over here at this smart contract. It's a safe. What we are basically doing is we are creating it with the owner. He has some special rights, and then we are tracking his balances. It's created over here, function safe, that's the constructor. And then you can do deposits. That's basically just depositing some ERC20 token in there, and they're getting stored. Later on, you can withdraw them. Yeah, it's already, and we will build a little bit on this very, very simple contract. What you can see here in the first line is basically that we are, again, working with the Gnosis contracts. It's very handy, but they are just the same ones as the ones from the Zeppelin ones or other ones.
I would want to ask you why you don't use ownable.
Yes, we like Gnosis is already in space quite a long time, and we started building all that when like the Open Zeppelin contracts were not as famous. But now it really seems that it becomes an industry standard, and now in the newer projects we're also switching to them, just because we think it's valuable for the whole community if everyone uses the same ones. Good. So we create very quickly this super simple safe contract. Good. So this was the very simple safe contract, and now we want to get the Dutch exchange as a dependency. So the first thing we need to do is kind of take a look at the Dutch exchange and see what kind of function we want to talk to. So within the Dutch exchange, I can open it here very quickly. Within the Dutch exchange, we are basically storing the price of all auctions, like of every auction that happens the last 6 hours. And now what we can do within the safe contract, we can take a look at the last auction price and basically read this one out and take it as an information. So we have over here the closing prices. They are just stored in a little bit more complex area, but it's very simple. It's just you're trading one token against the other token at a specific index. Like that's basically just the auction index, and then you store the price in there as a fraction. And all we want to know is basically what is the price of these auctions, and so we are basically reading out this closing prices. And there's even a function, last closing price. Get price of a token in the last auction. We can also use this one to really get the latest information. That's this function over here. It really gets the latest auction index just, and then gets the auction price. Good. So what we need to do, we need to now make the safe contract able to talk to the Dutch exchange. So we are importing the logic, copying it in here. And then we are declaring the Dutch exchange as a variable because we need to know to which contract, where the contract is stored, and where we need to talk to. Then in the constructor file, we need to see basically where this Dutch exchange contract actually lives, where it is, what is its address, and we're doing it the best in the constructor. It's just putting it in here. And we can also do something like update the Dutch exchange, but I won't do it right now. Good. And now the actual logic that we want to have in our safe is basically just tell us the balance in USD dollars. So what we are basically doing over here is we are so we are getting as an input a token address. And now what we want to know is the balance that we have of this token in our safe contract, and then we calculate the value in USD dollars. So the first thing we need to do is basically do the conversion from the token to the Ether token. And then from the Ether token, we can later on easily pull the information from the Maker and DAO price feed in order to get then the conversion rate between the Ether token and US dollars. And that's all what we're doing over here. First, we're getting the price of the token versus Ether, and then we are creating this price oracle interface and getting, that is basically the maker DAO feed, and then we are getting the USD price over there, multiplying it, and then you have it. So we can just copy this one into our save. Let's check whether it compiles. Right. So this is now a super basic application. You can do much cooler stuff with it. For example, you could limit the amount of withdrawal, which is somebody allowed to process, to some USD amount with that, so that you're really using the logic also in the smart contract and so on. And yeah, it's really just straightforward. I hope that you think as well that it's very easily usable. If not, please provide us some feedback. Then we are eager to improve it. It worked perfect. And probably the only thing that not yet worked was the migration script. Right? Cool. Perfect. That sounds very good. Then we have the confirmation that this also works. That makes me happy. And then later on in the tutorial over here, you find a little bit more advanced setups that you can do. Basically, you can already fund the save with some tokens and so on. And then later on, you can easily talk with the Truffle console to the smart contract and check some very basic things. So that's it for the very first draft start. Are there any questions? Are you guys interested in a particular thing? That makes me happy. And by the way, just for the record, like all these documentation and so on, they were not created by myself, but Andrew, one of our team colleagues, he really put a lot of effort into it. He did a really good job. And now I'm handing over to David. Do you need the adapter?
No. Are we not using the mic? Is the mic just not happening anymore?
Right.
Cool. There's just a lot of us here, so I want to make sure everyone can hear me. So show of hands, how many of you guys are coding your own front end, React, anything like that? And just let the record show that right now there's like 800 people raising their hands. So you guys are great. Hi, Mom. What up? Cool. That is my Chrome browser. Nice. That's all I wanted to show you at all. I guess I will show you this guy. There it is. Cool, so that's just a bunch of errors that I was getting. So the point, why is this so zoom? Is that we're gonna build this really tiny, I also have no idea why everything's green, but we're gonna build this really tiny, amazing front end that interfaces with the Dutch exchange and kind of just quickly run you through how we did it. And what I recommend is that you guys actually just clone the project because I feel like you guys are comfortable with NPM and all that stuff, so it's all good. Get that guy pulled up too. This is it. Get it over there. Everything's red. That's awesome. All right. So the basic architecture is pretty straightforward. It's the first one I'll go through is just the React one because that tends to be the one that most people are probably going to use. But we are using. Yeah, I'm really sorry for this really shitty quality. But the React version that we're using is the latest, so it's 16, and we're using the context API, so it's pretty straightforward, it's well documented. You can do this with regular components or with Redux, it's not an issue. It's easily built, but essentially what you need to do is outlined in the first two steps that Alex went over already. And so basically what happens is that you import everything. Once you clone the project, everything is essentially there. You will just need to install globally Truffle 4.15 and Ganache CLI for local testing, because I'm sure you guys have done this already. But what you can do once you clone this is you will have the contracts folder and the migrations folder already here. And you can do the very simple Truffle, or you can just do npm run migrate, and we will do everything for you, compiling and migrating. And since everything's already on Rinkeby, you can jump straight into that on the app. So once you do the migrate, make sure to install all the dependencies and then start the app, and everything will be shown here. So essentially what you can do is once you have it started is you can just go as usual onto your local host. So it's in 8080 on this one, pretty standard, and you will get the initial screen that looks like this. It asks you to select a wallet, so we basically just pre-coded in MetaMask because nobody else uses anything else right now. So pop that in, click it, and it's going to quickly load your state, check everything, and you can see how we read all the state from the app. So I think that's the really important bit. It's not really what I'm showing you here, but the idea that you can create these kind of APIs really quickly with the setup that I created with Dimitri and a few others on the repo. So essentially, if you use the same layout, you can actually map through the contracts that you migrate, and you can create some sort of API here. So in this example, I basically just went through all the functions that are getters and that are only view functions, so that you guys can actually just go ahead and check the value of certain functions on the Dutch exchange and just get a straight response right here without having to test too much. So as you're building out your applications, it's really nice to get some instant feedback. So here you can see who the auctioneer is. You can, at the very top, you can see we're on Rinkeby. Here's the account. Here's how much Ether I have on Rinkeby. You can check the internal contract addresses. And then, yeah, so you can check how much what the threshold is for a new token pair. You can see the ETH token address. You can pass in arguments and kind of get back the responses. So it is just like an API. You can use the DutchX API for this as well. But it is nice to see how the internals of a project like this looks. So we'll go through that. That doesn't matter. So in the source of the application, you have the pretty standard stuff. So you have an index.js, which just renders the application. You can import your CSS, etc. I'm not going to focus on that because it's not super important. What I do want to go through is the state provider. So I think this is probably the most important component that you guys would be or will be utilizing. And you can basically just plug and play with this one. So essentially what you can do here is at the very top is replace your state with the state that you like. I would recommend keeping it this way because it's pretty straightforward. So you have user state, provider state, DX state, contracts, and some sort of loader for anything async. And then the rest, here we create some memoized state mapping, makes it easier. But you can pass in your dispatchers like Redux right here. So here you can see a save the contract to state. Basically any contract that you map through, and I'll show you how this works. You'll save it to the application and you can reference it anytime. And you can get bounces this way as well. And then you can basically pass this component anywhere. And you are able to pass in state into your applications. And the way that this works is very similar to Redux again. But I can show you in the home component how this works. So you have a general home component, which shows what I showed you above, the provider state, network, account, bounces, and then the miscellaneous state, and then the mapping of the API. And the way that this works is you actually import connect, which is a component that I had made, actually that Dimitri had made on the other side here. So it's just this function here that we export. Again, similar to Redux, you pull it in, you can pass in the state into the component by wrapping it in it like an HOC. And here you can, at the very bottom, just as you would before, you can map the props to it and tell the component exactly what you want to see on the front end. So in this case, we're going to pass in the user state, the provider DX and contracts, and you are able to plug this in. So basically here, what we did for the API is go through the API of the Dutch exchange, which we had already saved in the component. And we're basically looking through the functions for certain ones, and then we're creating and writing HTML into the application so that the user can utilize the contracts with the front end. So this is a relatively archaic way of doing it. There's probably a cleaner way, but using, because I'm using element right, which is kind of weird. But in this case here, you can see that essentially it's checking the arguments passed into the form, and it's calling the Dutch exchange function name, passing in the arguments, and then you are writing in the response directly on the app. So basically, you can do this to bootstrap your Solidity projects really quickly, and just have at least some feedback to the users right away. And this way, since it's downloadable and clonable, you can fork it 1,000 times and get a general sense of the integration of everything else. We also do have a wallet integration component. I want to go through this one as well because I feel like this is one of these components, like it's rather convoluted in the space since there are more and more wallets coming out, and there's kind of a strange differentiation between them. In general, you have two kinds of wallets. You have the hardware wallets and you have the runtime wallets. The runtime wallets are the injected ones like MetaMask or Gnosis Safe or MetaMask. And so here you can see we do the same thing. We have internal state. We wait for a mounting lifecycle, and then we have an on-chain handler. And essentially what you can do with all these components, which is nice, is you can just download them yourselves and just use them on your own. There's no real need to change anything else. And you can utilize our API instantiation as well. So what this component does is it wraps your application and anything that you'd like to render after, so make it top level, and it will inject whatever you've had saved in there. So in this case, you can see that it actually is doing a little bit more than just integrating wallets. It's choosing the provider based on what's injected. So if you have MetaMask injected first, it'll read that and it'll basically read the constructor name and tell you, oh, this is MetaMask, or it'll be, oh, it's not Gnosis Safe. It'll save it to state by name. We will instantiate the provider by creating an initialize function, which basically grabs state from the provider and saves it to your app, like account balances, network, etc., using the provider object. Then we will get the app contracts. So this is an API that we created up here. In this contracts folder, it calls this, which essentially means that here you can swap these array items for the names of your contracts if you want to include more into the DX. And you can just kind of make sure to change all the names appropriately. It's not plug and play right now, but essentially it's pretty straightforward. You just kind of control find or whatnot, and you can essentially just pull in all the relevant network data, and you will deploy all the contracts via truffle contract with the deployer that, with the provider that your app has detected initially. And then once you have that pulled in, if I go back to wallet integrations here, you will have the contracts deployed and saved into the application at that top level state, and we'll get the APIs. We have a high level API for talking to all of the contracts, DX, tokens, etc. It'll grab the user state, which is, as I mentioned before, just the basic accounts, balance, etc. And then it will only load the app once all that information has returned. So we have like I said, we have a loading async state prop here, which will say false, and it will return the app. And otherwise, it'll just show a loading or spinner, whatever you want to plug in. So this allows the app to be rather flexible and allow you to kind of, as much as possible, we try to abstract this where you guys can take it out and use it on your own without, it's not coupled to very much stuff. I mean, it is coupled to the DX, but that's kind of the point. But if you don't want it to be coupled to the DX, kind of just take out that kind of stuff and you can put it, replace it with your own. I think it makes for an easy template. So that's kind of the approach we've taken. So we have a high-level API, which instantiates contracts and the provider. Then we have the wallet integration, which sets up your specified wallet that you want to use for the app. And then you have the state provider, which you can pass around throughout the app to have a high-level global state to store whatever you want to store and easily pull it out using the context API. On the flip side, if you don't want to use any of this stuff and you have no idea what the hell I'm talking about, you can also use the no front end framework. This is basically a framework that is built with vanilla JavaScript, whatever that is. And you can, where is it? Here, you can see how we built this using just good old JavaScript. It is using Parcel, so you can do npm start, I think it works. But everything else is just normal JavaScript, no frameworks. And we just it's kind of like a jQuery-esque approach, but I'm not going to go too much into this one because it's just JavaScript. And you can go through and take a look how this is done. It's the same exact application, whatever tickles your fancy, just use that one. If you have any questions, I would prefer that you guys use the React one, it really doesn't matter. I'm more used to it, but it's just in case you didn't want to learn a whole new framework, it's there for you guys. It uses the same exact ideas behind it. And again, you can fork this and easily adapt it to your own needs. And that's the beauty of it. And we also do have a Truffle scripts integration where you can kind of see how we utilize Truffle frameworks scripting to execute certain test functions in their own environment, which is also useful for testing. Cool, so that is the front end side. Again, the stuff is, it's here. Same place as Alex showed, so GitHub. Typing on the mic is really cool. I'll put it down here for a second. Cool, so yeah, everything's here. I mean, you have the stuff that you can just clone, and all the README information is here. So I've outlined this already, but make sure to have Ganache CLI and Truffle 4.5 installed globally. And then you can basically just go through this if you have any issues. There is a troubleshooting section, so if you are building and you run into this issue, it's probably a Node.js error. Just talk to me about it, we can go through it. The whole point of this is not to spend 100 hours trying to get NPM to load the project. So this is why it's relatively simple. Yeah, cool. So that's it. If you guys have any questions, obviously, I'll just wait for them for tomorrow. I think it'll be easier as you're building to go over them. This front end is pretty arbitrary. But I hope that you guys can use this, and other people out there watching can also use this to bootstrap their projects. And yeah, if you have any issues, leave them on the GitHub. If you like it, send me ether. Yeah, shameless plug. Yeah. Thanks. You saw it, yeah? Cool. Were you able to clone everything? No issues? I mean, you're familiar with React? Yeah, I think that should be the, I mean, it's easiest to start working with as a non-React one, but I think in the long run, the React one just makes it easier once you get more projects. Sure. Yeah. Yeah. Everybody goes that way. Yeah, no, so the API that we use for React here is a little bit different. Most of our project is actually almost all of them are Redux in React. We decided to kind of take a step back on this one because it's a little bit too heavy. It's just too much stuff. And I find that this iteration that we created is actually easy enough to bootstrap and a little bit easier to understand than the trouble. I don't know if you've used that one, but it's kind of pretty high level.
Cool. Thank you, David. Thank you, Alex. That was great. I have only 3 more slides for you guys, assuming that most of you are in town for the hackathon, or those people who are live streaming right now. Just leading up to that, we have some information. So we additionally to the prize, we are also giving out a DutchX specific prize. We've really put a lot of effort in putting all documentation, information, building on top, anything that developers might need or anybody else interested in the DutchX onto one kind of central website where you can get all this information from. So this is the QR code. And ultimately, the idea really is to attract more users and integration and liquidity. So I'm just going to stop right here so you can all take a picture. Okay. So it's actually 5,000 euros in G&O that can be won additionally to the prices, to other prices on the hackathon for the DutchX integration. And for this, I was thinking kind of to give you some inspiration of what could be potential integration cases or ideas or use cases. We actually have a larger selection of those on that website, read the docs that you took the QR code scan off. And I was going to highlight a few here. So if you have further ideas or you need further inspiration, feel free to roam the ideas that we've put on there as well. Some of them are quite detailed, others are not so much detailed, just in case you kind of want to take it away and make it your own idea. So some of them I've listed here. So what is end-to-end participation, or I call it end-to-end participation, but really so for somebody who might be active on an interface, like a trading platform that taps into the smart contract layer, so that is kind of allows the user to use the DutchX protocol, they will have to go through a lot of transactions. Wrapping Ether if they don't have wrapped Ether in their wallet, then they will have to kind of confirm paying an owl if they want to, the fees, they will set an allowance, they will confirm this, they will claim and withdraw. So you have a lot of transactions. It would be so much easier for a user to have another smart contract interacting in between them where they can just send Ether. The smart contract does everything that they need to do, participate in the next auction, and actually actively gives the exchange tokens back to the wallet address that the user wanted to participate in. So that is kind of one idea that would be super useful to users. Another idea, obviously, is building arbitrage bots. There could be, for example, another smart contract, for example, that roams other exchanges at once. The price on another exchange has reached a certain price where it's useful for you to participate on the DutchX, because the DutchX price, say, on the bidder side is exactly the same price, i.e. the exchange guarantees you that price or a better price. It is actually worthwhile to do arbitrage. So that could be another idea. Then also, you might have read some news lately that many token projects are actually wanting to buy back tokens for various reasons. Could be for kind of financial stability or to reduce the amount of tokens. Many of those actually already promise this once they do their ICO. So there is a need for projects to do buybacks, and possibly together with a burn or burning those bought back tokens. It is not that easy to perform token buybacks because you kind of have to commit to it publicly. You have to say what you're doing, how much you're doing, on which exchange you're doing it, and you have to kind of stick to it. So there could be another smart contract where a token project would put in, okay, this amount in ETH, we will buy back in our token, we will participate in auctions, auction index 17, 18, 19, and 20, or whatnot with this amount, and then they've locked it in the smart contract and it will be executed anyway, sort of, that's another idea. Then you can have all sorts of data analytics, be it volume, show Ether in US dollar prices, anything really, how much fees are being rolled over to the next auction, anything that might be useful for a user of a graphical interface. And then you could have an automated token listing bot because, and I didn't go into the detail with the mechanism, anyone can add tokens to the exchange following a set of rules, which is initiating a particular pairing with a particular token with ETH, ETH being the sell volume, which has to match 10,000 US dollar. Either that could be kind of a pooling contract if more parties are interested, and then it would have to be bought back with the token that you're actually trying to list. And then the auction, and for the first one, you will also need to set a price. So it'll be cool to have something automated who does that participation for you. Kind of any ideas go, so these are not any better ideas than any others. It's just to give you some inspirations that really there is a lot of things that could potentially be built on top of the DutchX. Lastly, not quite lastly, but just what we'll take into consideration when we look at the submissions. Firstly, the idea, kind of the use case, how relevant it is, and also sort of if it reflects the values we are trying to achieve with the DutchX, which is kind of fair and decentralized. The second one is technical difficulty. That's really an easy one. It goes from how complex it is, the implementation, kind of documentation, is it bug-free, etc. Does it go beyond what we provide you as the documentation? Third one is usability for others. And that is really either on the technical integration part, so can other people reuse what you've done, or is it usable for an end user if you're targeting an end user? We have size of potential users. It really goes to liquidity per users and how many potential users would there be of the integration case that you have then submitted. And lastly, has this gone beyond expectation? Is there an additional wow factor in your submission? And if you can't decide, oh my God, I have so many ideas, what should I do? Then just ask yourself, what is actually bringing more liquidity to the DutchX? Just as a deciding factor if you have too many ideas. Just some of the details, but we'll also post all of this on that read the docs that I was referring to earlier. Submission is Sunday, 12:30 because 12 o'clock is the official deadline for the East Berlin, so we'll just give you a little bit more time to submit it also via Gitcoin. Please include team and the business idea behind it. It has to be a serious idea. It can be on localhost or it can be on Rinkeby. Smart contracts are also on Coven, but we prefer Rinkeby. It has also reorgs and it mirrors a little bit better the mainnet. Then on Sunday afternoon, you also be pitching the idea, so you have to be actually present, and it'll be a really short pitch of the business idea, just 5 to 7 minutes. And as I mentioned, the winner is to take away some goodies, but also 5,000 euros worth in G&O. And this is additional to any other prize you might win on at the hackathon. The same rules will apply. You may only start bidding once the hackathon officially kicks off, and we'll be announcing the winner then together with the other prizes. And if you need any support, we'll probably be also reachable remotely, and information to be found on the Read the Docs, but also we'll have a booth, a Gnosis booth at the hackathon, so you can come by anytime, and also the 3 of us and some more will be there to give you support in case you need to. That's it. Do you have any questions? No? More information on that QR code. I saw you all scan it, so that's great. And yeah. Cool. I think that's, yeah, you can also come here. Perfect. Cool. If there aren't any questions, I think we can shut off the live stream as well. Bye. Come bitte. Perfect.